Hello everybody, I'm Nick, and in this video I'm going to show you how we can use mock in order to do mocking in our unit tests in .NET Core. Mocking is, put very simply, the idea that because every class has dependencies and we don't want to go over the network or to the file system because of these dependencies, like a repository that goes to a database for example, we will mock to essentially simulate the behavior we expect this dependency to do in order to test the unit, which is potentially just the public method we want to use that is using normally a database call. And I'm going to show you an example of this in an API that I have. But before I do that, I want to remind you that until the 2nd of February 2020, I am running a giveaway in collaboration with JetBrains, giving away 5 one-year free keys for JetBrains Rider. Rider is the IDE I'm using, and I highly recommend it for C#. In order to participate in the giveaway, you have to click the link in the description and follow the instructions, which mostly consist of you being subscribed to the channel and ringing the sub notification bell. This video is part of my Essential and New Gear Package series, so if you don't want to miss any episodes, please subscribe and ring the sub notification bell to get notified when I upload a new episode. So as you can see here, I have a very basic customized controller in an API, which has 2 endpoints, well 3 really, which is the create a new customer, get customer by customer ID, and get all customers, and that's it. And in order to store the data, it's using SQLite, which is a very lightweight database which I'm using in this scenario. And I can show you here in Postman that when I hit the endpoint, I am getting just one user here, and if I want to create a new one, I can give it another name like this, and then when I click send, you can see that it created that. And then if I get everything, I'm getting everything, and if I use the ID, I am getting the one that has this ID, and if it doesn't exist, it will return a 404 not found. So behaving sort of like a REST API. And you can see here that all I have is a customer service, which is using a repository and doing some mapping behind the scenes. And the repository is connecting to the database and it's running these queries in order to do, well, the querying. You can find all this code in the description down below. So if I close that, I think you understand what's going on now in our controller. And what I want to test is, I want to test the customer service. Now the customer service as a class has 2 dependencies. The iCustomer repository, which is an interface which I'm implementing with my customer repository, and the iLogging service, which I'm implementing with the testable logger, because the .NET Core logger is quite hard to test and it is mockable, but I want to keep this video very simple. We're going to see tricky scenarios in a future video. So for that reason, I created a wrapper that allows me to unit test this very easily. And these are the 2 dependencies I want. So what I'm going to do now is I'm going to test a couple of methods in here. And the first thing I need to do is to create a test project. And I'm going to go at my solution level and say new project. And I'm going to pick here the unit testing project in Rider, and I'm going to call it customers API.mock. And the reason why I'm using this name is because I'm going to do a similar video with nsubstitute and fake it easy, so stay tuned for that. And all I need is xunit here, C#, and that's all correct. So I'm going to add this. So with that added here, as you can see, I'm going to go ahead and add my project as a reference in order to use everything in there. And then I get this unit test 1 plus, which I'm going to rename now. And the way I like to name my classes when I'm doing unit testing is I'm using the name of the class that I'm testing. So customer service, and then I put tests as a suffix. And this is now my class. And what I'm going to do now is I'm going to write a method which reflects what I'm going to test. And for this scenario, I'm going to use a public async task. And the way I name my tests is I'm picking the name of the method I want to test. In this scenario, I'm going to go with get by ID async. So get by ID async, and then I say should return customer when customer exists. And this is my test. Now, in order for this to actually be found as a test, as you can see in the very bottom here, is I need to add the fact attribute. And once I do that, if I close this, you can see that my test is now discovered. Now, I like to break down my tests in 3 sections, and I'm using the AAA approach, which is arrange, act, and assert. So in arrange, I'm going to arrange everything I need to use for this test, things I expect to see and stuff like that. Then act is where I'm doing the call of the method I'm testing, in this scenario get by ID async, and at the end I'm asserting the values from the act section. So as I said, we're gonna test the customer service, and this customer service has two dependencies. One is potentially going to the console or the file system, and the other one is going to a database, and we don't want to do that in unit testing, because in unit testing it's very isolated. It doesn't go over the network or on the file system. So what I need to do is I want to mock those two interfaces, and them being interfaces is very important, because only interfaces and abstract classes or abstract things can be, and also virtual, can actually be mocked. Other things cannot be mocked, so keep that in mind. So what I'm going to do is I'm going to add a NuGet package here, and I'm going to say mock, and it's the first package you see here. It's the most popular mocking framework for .NET, so it should be easy to find. So this is now here, and I'm going to create my system under test first. So I'm going to say private read-only customer service, which is what I'm testing. And I'm going to name it underscore system under test, so SUT. And I'm going to create the constructor, and in the constructor I'm going to say new customer service. And as you can see, it needs two things, the iCustomer repository and the iLogging service. So this is where a mock comes into place. I'm going to say private read-only mock of type iCustomer repository. And here I say customer repo mock equals new customer repository mock. And that's it, I have my mock. And then I need to do the same thing for the logging service. So iLogging service goes here, and then I'd just say logger mock equals new logging service. And now I have these new objects. By default, they have no behavior. So if I do anything with these methods, with these mocks, my tests won't behave the way I want them to. I will need to set them up. And this is where I'm going to focus with this video. Just setup of mainly methods, and I'm going to show you how you can do properties, because that's the most common thing you will actually have to do. And I'm also going to show how you can verify that something has been called the exact amount of times in these mocks, because this is the two most common scenarios that you need to be aware of. There are other things like event handling and potentially things like callbacks, but these are advanced features that you probably won't have to see on a day-to-day basis, and there's plenty of documentation of that. So I'm going to show you how you can get started and do potentially 80% of all the use cases with mock. So first we need to say customer repo mock.object, because that's the first thing we have here, and the next thing is underscore logger.object, and by object we're getting the interface which behind the scenes mock will implement with the proxy class, and that's how it actually mocks the behavior. It creates an implementation in memory for that interface. With that out of the way, we're ready to write that test, and let's see what we want the act to be like and the assert to be like, right? We want to see that we can get a customer by ID. This is the main goal. So I'm going to say result customer, or just customer in fact, equals await SUT get by ID async, and the ID will need to be a GUID. So in our range we're going to say var customer ID equals GUID dot new GUID, and that's it. And now I'm going to copy that and paste it here, and this is what I want my act step to look like. Now of course I need to assert that other things about the customer are coming as expected. In fact, if I just do this now, let me just bring this window up, and I add an assert clause which says assert that equal, and what I'm expecting is the customer ID, and what I'm testing it against is the customer.id. If I do that and I run my test, you will see that the test will actually fail. Wait a second, that's not what I'm testing against. I want to test against the customer.id. Here we go, sorry for that. So if I run this now, we will see this failing, and that's because it will actually not have, it will throw a null because the mock is not set up. Let's see how we can set up the mock, and actually let's see what this method looks like. So as you can see here, we have a call to the repository with get by ID async, and this repository goes to a database, And this is where we provide the customer ID and we get a customer back or not. And if we don't get one, we get null back. And we also do some logging here. So what we really want to mock here, and we have to mock this is the get by ID async. So how do we do that? Well, we find the mock we want to mock. So the mock class that we want to mock, and we say customer repo mock dot setup, and here we choose the method we want to set up. In our scenario is the get by ID async. Keep in mind, even though they have the same name, this is the service call, the system under test, this is the repo. So don't mix them up, they're totally different things. This goes to the database, this goes to this. So what we want is to verify that if we call this method with this customer ID, and this is where this goes here, then this method returns async a customer DTO. And this customer DTO, we're gonna have to create ourselves. So I'm gonna say customer DTO equals new customer DTO. And this DTO will have the ID that I have here and the name that I'm gonna give it. And that name, well, that will be my name. So actually, I will not even create it here. I will create it as a local variable. So customer name equals Nick Chapsas. Here we go. And I'm going to use that as the name. And the reason why this is complaining is because the DTO actually stores this as a string. So I'm gonna have to do a toString here, but that should fix it. And because this is an async method, I'm gonna use the returns async method. If this wasn't an async method, I could simply do returns and provide what I'm returning, in this scenario the DTO. So this is now set up, so that's it. And if we run the same test with this setup, I expect this test to pass. And sure enough, my test is actually passing, because now the setup method of the mock is telling, please return something that I created here in memory, in this scenario the customer DTO. So this is how this part works. And in order to verify that everything is mapped correctly as well, we're gonna say that assert equal customer name, and that should be equal with the customer dot full name. Also, I want you to see that if I replace this with the actual class, which is the customer domain object, this and this are totally different objects. And what we're really testing here is that the mapping from one object to the other actually works fine. So if I revert that and I run my test again, you should see that my test is passing, validating the behavior. And now if I do cover selected unit tests, you will see the unit test coverage window pop up here. I can actually go to this method and show me exactly what line is covered by the tests. And if I click here, it also shows me the test that is covering this line. Test coverage is something that we use to see which test and whether a line is covered by a test. That's basically it. And we can see here that this part is not tested, and this part is testing the customer is null behavior. So let's go ahead and test that. Should I just copy the whole thing? Let's just copy the whole thing and create the test again with some modifications. So just copy this. And what I want to test is get by ID async should return nothing. So renaming this nothing. When customer does not exist, let me close this window. So when my customer does not exist, this returns nothing, so null. So I'm gonna just delete that assert step. This will stay the same because this is the same. I'm gonna delete that in the arrange. And what I will say is that here I do not care what the ID is. Any ID in this scenario should return nothing back. For that reason, I'm gonna say that it is any GUID. So any GUID should qualify for matching this setup. And on any GUID in this scenario, return null. Now, why do I do this lambda function approach? Is because if I remove the null here, the null cannot actually be inferred to a type because it's the async method. If this wasn't the async, it would work. But know that this is how you do null here when you have an async method. So this tells it that when this method is called with any GUID, please return null. And because this returns null here now, we will fall under this little block. which will return null. So what I'm asserting against is get GUID by ID, and I can simply say GUID dot new GUID because I don't care about the GUID here. I could very much create one and use it in both places, but in this scenario it doesn't really matter. And I can say dot assert dot null and customer, and I'm gonna run this, and this should also pass. By the way, the reason why I'm using the built-in assert of xunit and not something like fluent assertions or shouldly is because I actually have a video for these two packages as well as part of this series. So we're gonna take a look at them then. And as you can see, both tests passed. So this is the very basic scenario of setting up a method, and in the same way you can also set up properties. You could, if we had a property, you could say customer repo mock dot setup property, and you can also set up getters only. There's tons of documentation. This is just showing you the most common scenarios. You can find a link in the description taking you to the mock documentation, and please leave a star to the project because I think it's a great project. Now, if I run this coverage thing again, you will see that it looks like everything about this is covered, and that's because the test will actually traverse the method in its entirety. But as you can see here, we're also doing some logging, which doesn't return anything, but it is being called nevertheless. And the reason why the tests are not failing here is because this is a void, this will just be essentially mapped to nothing and ignored. So what we want to do, and what we should really want to do if logging is essential to us, or even metric collection, if you have an alerting system on top of metrics, that should be very important to do, is to ensure that these things are actually called. And how do you do that with something that doesn't actually return anything? Well, I'm going to show you. It's actually quite simple. So I'm going to create a new fact here, and that will be a public async task in the same way. And I'm gonna use the same method, get by ID async, and I'm gonna say should log appropriate message when customer exists. It's a long name, but I prefer long names because they're very descriptive and I don't need to leave comments, so that's why I'm using them. And again, I have my AAA generate here, and I'm gonna write the code that I need. And ultimately, the act will still be the same. And in fact, I can copy the whole range and act from my first test, and I'm gonna paste that here. So as you can see, we're still setting up a new customer to be returned here, and we're gonna change the assertion. And why do I split these tests if the code is the same? Well, the reason why I do this is because I like my unit tests to test one thing only. I could very much group them and put the assertion here, but then what is the purpose of this test? What is it testing? Is it testing that the user is mapped properly, or that my logging message is appropriate and correct? So for that reason, I split them. Now, if you don't want to do that, well, feel free to not do it, but I think it's a best practice to split them, to make them clearer. So in the assert method now, as you can see, we have the same mocking, but we also have the logger mock, which we do not set up because we don't need to set up. But what we need to do with it, because it will be called here, in fact here, is to ensure that this message is called and it's logged and it's correct. And in order to do that, I'm gonna say logger mock dot verify, and this is what we're doing here. We're verifying that something is called. And what are we verifying? We're verifying that log information with this message is called, and that's not enough. We also need to specify the parameters, and the parameters is the customer ID, so I'm gonna put that here. And now this should be enough. In fact, if I just run this, it should just pass, and as you can see, it does pass. But in order to be more specific, I want to put a comma here and say times once, because I want to ensure that this will only be called once. And if I run this now, here you go, my test did pass. And you can also verify that something is not called, and let's just show this with this other message here. So I'm gonna copy that message, and potentially this double check here is not what you would do in a realistic scenario, but I'm gonna use this opportunity to show you how you can test that something is not called. So this should not be called, and for that reason, and the parameters is again customer ID, And for that reason, I'm gonna say times dot never, and this is never called. And you can see here that if I just click dot, you have things like at least and a number, at most and a number, at least once, at most once, exactly, and between. I'm gonna go with never in this scenario. And if I run my test, I expect it to pass in the same way. And as you can see, it did indeed pass. So now I'm verifying that something that doesn't return something is called with the appropriate parameters. In fact, let me show you what it would look like if that wasn't the case. So retrieve the customer with ID this is what my current test is doing. But if I change the method with ID this, and I could say something like end name, or if I say successfully, I probably misspelled that. Okay, it was correct. So if I change the message to successfully retrieve the customer with ID, now if I check in this code without running the test and my CI runs them, it will ignore this build because my test will fail because the message here is not what the unit test is expecting. So my unit test is failing and it's doing its job because it's making sure that this might be critical for the system. You cannot just change it without updating the test as well or without knowing that there is a test. These are the two basic things that I want to show you about mocking in this context. There's way more methods, but I think they're much more niche than setup and verify. So for that reason, I want to stick to just that. And if you want an advanced mock video, please request it in the comments and I'll make one. You can find the full documentation of mock in the description down below. That's all I had for you for today. Thank you very much for watching. Special thanks to my GitHub sponsors for making these videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well to get notifications when I upload a new episode, and I'll see you in the next video. Keep coding.